A wonderful day to all of our guests and viewers. Welcome to once-in-a-lifetime experience that you'll never forget, to the Mathematics Global Conference. This event will definitely blow your mind, as adding the IQs of our guest speakers will make a supernova of brain cells. Let's not waste our time and let me present to you the four greatest mathematicians of all times: Mr. Albert Einstein, Mr. Isaac Newton, Miss Sophie Germain, and last but not least, Mr. Leonardo Pisano. Let's start with this special pen that will hold the key to wisdom, the pen of knowledge. I will pass this to our first genius as they will tackle about the Webster method, and he will pass it to the next until it comes back to me again. I'm so excited! We shall now start to Mr. Isaac Newton.
Thank you, Ms. Flores, for that wonderful introduction. I am Mr. Isaac Newton to explain to you who is Daniel Webster. Daniel Webster, 1782-1852, proposed a method similar to Jefferson's in 1832. It was called what we know today as the Webster method. It was adopted by Congress in 1842 but replaced by Hamilton's method in 1852. It was then adopted again in 1901. The difference is that Webster rounds the quotas to the nearest whole number rather than dropping the decimal parts. If that doesn't produce the desired result, as the beginning he says, like Jefferson, to adjust the divisor until it does. In Jefferson's case, at least the first adjustment will always be to make the divisor smaller. That is not always the case with Webster method. And that's it. I am now going to pass the pen of knowledge to Mr. Leonardo Pisano Bigaldo to broaden your knowledge and familiarize you about the Webster method.
Grazie, Mr. Newton, for that wonderful explanation. I will now take the pen of knowledge for I, Mr. Leonardo Bigaldo Pisano, will turn to elucidate the terminologies in this juncture. I will now begin to the Webster method of apportionment. The Webster method is a modified version of the Hamilton or Vinton method. After the state populations are divided by the divisor, those with quotients that have fractions of 0.5 or above are awarded an extra seat. States with a quotient with a fraction below 0.5 have the fraction drop. There are two calculations of Webster method. The first calculation is the standard calculation, and the second one is the modified calculation. And for the next term, the standard divisor. Determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. The answer that you will get there is called the standard divisor. And for the next term, the standard quota. Divide each state's population by the divisor to determine how many representatives it should have. Record this answer to several decimal places, and the answer that you'll get there is called the standard quota. And for the next term, the modified divisor. Modified divisor is a number chosen by trial and error that will be used to divide each state population if the standard version does not result in the correct number of seats to be assigned. That's all, my fellow spectators. I will now pass this instrument to our next mathematician. Arrivederci.
Merci, Monsieur, Mr. Pisano. Pardon, I am Sophie Serman, and I'm going to teach you how to utilize the Webster method in our problem. There are 4 steps that you just need to remember. It is just a piece of cake for you, my students. Let's now go to our first problem. The legislature in a state has 44 seats. Apportion these seats to the 5 counties below using Webster method. The first step that we are going to do is that determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor. So here's the data. Look at it very carefully. Let's check the total of the population in the calculator. We are just going to add these numbers. And voila! It is correct. The second step is to divide each state's population by the divisor to determine how many representatives it should have. This answer is called the quota. And the third step, round all the quotas to the nearest whole number. Add up the remaining whole numbers. As you can see, we divided each data in the population to the standard divisor. And so on, and so forth. Then we add up the rounded quotas and compare it to the given. As you can see, it is the same as the given. Thus, we already solved the problem. And that's it, my students. But there's still remaining last step. We will going to apply the step 4. If the total from step 3 was less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from step 3 was larger than the total number of representatives, increase the divisor and recalculate the quota and allocation. Continue doing this until the total in step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. In this case, we will use it to our next problem. Let's now proceed. The number of salespeople assigned to work during a shift is apportioned based on the average number of customers during that shift. Apportion 15 salespeople using the Webster method given in the information below. We will now do the first to third steps using Webster method in this problem. As you can see, the total initial do not match the given, so we will now do the fourth step. Let's try 90 as a modified divisor to check if it matches the given. We will check it to the calculator to get the quotas needed and round and add them to compare. As you can see, it still didn't match our given, so we will going to add more. Now, let's make it 92. Let's calculate again each quotas and see if there's any difference and adjustments it will do to our solution. And voila! Look at the total initial and it says that it is the same as the given. Thanks to our modified divisor, we will be able to attain the solution to the problem. I assume that is all the knowledge I have to share to you, my dear students. I hope you learned so much from your Madame Sophie. Now I will pass the pen of knowledge to my dear Mr. Einstein and he will now take over this lesson. Au revoir.
Thank you, Miss Germaine. My name is Albert Einstein, but you can call me Albert, for that is my first name. Now, a lot of you might be asking yourselves, why does Albert Einstein look younger than he did before? Well, that is because I am. For just like time, this mustache is nothing but a stubborn illusion. But that is enough about my mustache. Let's talk about apportionment. More specifically, Webster's method of apportionment. Now I assume that you already know that apportionment played a huge role during the 1700s in the US Constitution when the House of Representatives tried to apportion themselves, and they came up with not only one but a couple of methods to apportion, and one of which is Webster's apportionment method. Well, some of you might be wondering, what is the point of learning all of this since not all of us are going to the Congress anyway? While that may be true, that not all of you are planning to go down that path. It is also wrong that you shall not require new knowledge. You see, a great mind once said that the more the knowledge, the lesser the ego. But The lesser the knowledge, the more the ego. Now, it wouldn't hurt to learn something new every once in a while, would it? But, going back, Webster's apportionment method doesn't only have to deal with the apportion of seats in the Congress, for it also helps us to determine the number of hospitals and where they should be built, the number of teachers and where they should be employed, or the number of policemen and where they should be assigned, and all of which could be determined by finding out the population of a certain town or area. And with that, I conclude my lecture for today, and I'd like to pass this pen back to Miss Flores, but as I do, observe, for you would also be able to witness one of the fundamental forces of our universe, gravity.
Behold, the weapon that holds so much intelligence and now is in my hands. It is such an honor and an unforgettable experience to learn from our well-known mathematicians. We are very much thankful to your lectures and wonderful contributions to our world. Once again, thank you very much, and I hope you learned so much from this conference. This is your beautiful host, Miss Flores. Goodbye and thank you for watching.